I don't know what view. I see comments here. Yeah.
Yep.
Guest chat. So
Alrighty.
I don't know what view anybody sees now that we're remote, but
They see us right now.
like in our traditional view.
Yeah. Yep.
Okay, sweet. And then my screen's not being shared.
Not yet. I can move it there.
No, it's okay. I just this show is raw. Okay, we're not heavily produced, so we were doing a podcast and I couldn't get Kevin to get to the house fast enough, so we just decided to do it like this today. And I was at Google I/O last week, so we didn't do anything last week. So we got to go back through the notes. And oh, weren't we supposed to have Mohammed on today?
I need to get Mohammed's email from him.
He,
I don't know
he
if you're in
definitely he
contact
sent
with him.
me an email. I guess I didn't send it to you.
Oh yeah. No.
All right, we'll work on it for Thursday.
Yep.
Um, I know he sent the email, but all right, we'll work on that for Thursday. Now that I'm thinking about it, just today's a busy day with podcasts and stuff.
Yes.
All right, switch over um, to my share here.
There we are.
I think I I think I remember we were going to start doing some socket stuff, but let me go back to our notes here. So we got the agent to agent communication working, which is still pretty crazy the way that was sort of interacting, even
Yep.
with part of the prompt being wrong, your side of the prompt being wrong, still
It was
behaved.
just inferring, making its own
Yeah,
decision.
I guess it was inferring a question or something. Yeah, it's
Yeah.
super interesting. Um, and now we were using the 3-2 llama model.
Yep.
So I go back. I keep sort of struggling with the whole mesh service, Google Cloud Run, socket level communication. I can't even remember what that. I want to do the socket level communication from cap to cap. That is for sure. Um, because I think it would be nice to get off of NATs at some level and be truly decentralized. Like you're never going to be 100% decentralized when we're depending upon another sort of tech to do things, right?
Exactly. Yep.
But once you do that, we need to be able to configure what cap somebody's on. Instead of trying
Hmm.
to do, say, cap discovery, because we're going to be on a big public internet. Like if you're on a private network, then you could do service discovery and stuff like that. But on the big network, I don't know how valid that is. I've never even tried it on a big network before. Now,
Got it.
I
Okay.
did write here mesh service, so Google Cloud Run, socket level communication. Once you deployed um, once you deployed your something on the public internet, then it wouldn't matter. But one of the things that Florin and I are looking at right now, so I totally don't remember what that is all about, but one of the things that we were going to play with for prediction card. Let's get rid of this for a second. Um, is leveraging Tailscale.
Yeah.
At least learn how to use it, because if Tailscale does let us establish a peer-to-peer connection over networking devices, like what we talked about last 2 weeks ago, the the modem you have in your house, right, which is giving you internet access, which is doing NATs, right? Remember, I showed you we both technically have the same IP address on
Yeah.
the public internet, right?
Exactly. Yep.
So, but the idea of Tailscale is if we run a little Tailscale client, then the internet and all the devices in between don't matter. And it's not a spoken wheel like we would have had with ngrok. If we used ngrok, then we're asking all the traffic to go to ngrok first, right? They could, even though it's encrypted, let's say, they get to see it because they're basically proxying the traffic. If we could figure out how to get Tailscale to work, where we both run the Tailscale client, then what happens is we could establish a true peer-to-peer connection, and there isn't anybody in between sort of reading it first and proxying it. So
Okay.
we're gonna write some code today, but because we're not in the same room, i.e., on the same local network, we're not gonna really be able to test it between the two of us. I'd have to run another client here, uh, running another cap, and maybe we'll see what time it is. But maybe what we'll do today is try to. I don't think we'll finish enough of the code anyway today. And then
Okay.
next week, if you're here, since we're on the same local network, remember I showed you the local IP address you had, the 10 dot something.
Yep.
It's either 10 dot or 192.168 something. Then we could try it. Once we know that works, then the next thing would be to get Tailscale working where you're at home and
Mm,
we're just connecting.
got it. Okay.
Yeah, right. And then instead of doing service discovery, we could just change the config to specify your IP address, whatever that looks like. I have no
Mm,
idea. So, um, yeah, it's all interesting. I'm going to learn a bunch of stuff here. My networking foo is fairly weak. I understand the socket communication stuff, and we'll do all that. But what Tailscale is doing is a whole nother level of networking configuration.
s-
In fact, the
so
last guy we just had on the podcast, Calico, it's all about networking.
got it. Okay. And so tail scale, is it exactly that they do that's like different from, let's say, like
It
NATs?
opens up a hole between my house and your house
Okay.
without needing somebody in between to sort of proxy the traffic. So they're
Oh,
gonna
okay.
they're
Got it.
gonna
Got it.
open up a hole between all the networking devices, as so it's gonna make it as if we're on this as if you're sitting next to me on the same local network
Got it. Okay.
without having to do anything. The idea would be to just run the Tailscale client. The idea is you run the Tailscale client, I run the Tailscale client. There's a tiny bit of config, whatever that looks like, and now
Yep.
I can establish a connection to computers if you were sitting next to me,
Got it.
uh,
Okay.
like our first run will go. And a lot of
Makes
people
sense.
are loving it because now they can be somewhere on the planet and they don't have to set up a VPN. They just run the client at their house, and they could be in Europe and establish a connection to those machines, a secure connection to those machines in their house. Like that's the idea.
Got it. Okay.
That's the idea.
Okay.
And Florin and I want to play with it for prediction guard because we want to do some cluster to cluster communications where clusters are running even in different data centers. Think about the amount of networking appliances are sitting between just
Mm,
cloud infrastructure, right?
yeah.
Um, well, I don't. If you read the tail scale documentation, they're really going out of their way to say it's not a VPN. Um, it's just and because they don't see any of the traffic. They do have a I'll just call it a centralized database that has some configuration knowledge in it about something about you, but the actual networking connections don't pass through Tailscale like a VPN or an ngrok. You do get a pure peer-to-peer network
Mm,
connection. So read the Tailscale docs because if they were just doing that, they'd just be another ngrok or VPN service. There wouldn't be anything really magical or special about them. Okay, so we're gonna do this. Okay, we're gonna do some socket to socket. So basically, the idea would be that this cap can connect to any other number of other caps TCP wise directly. One
yep.
would be listening for connections, and one can establish a connection. So all the caps would have to be in some sort of accept mode, and then another cap would be so think of it server client almost, where one would act as a server and one can act as a client. So we also got to figure out um, at some point because we can do bilateral communication on that connection. It's not just one way, right? The idea wouldn't be that my cap connects to you and your cap connects to me. It would be one or the other chooses to establish which is really super interesting. when I think about that. So that's a separate problem that we're going to have to deal with. Like, how do you decide that you're going to be the client or I'm going to be the
Mm, okay.
server, right?
Yeah.
Yeah,
Mm,
we'll deal with that. Like, and it shouldn't matter who's the other one, right? Like, maybe when you come up, you try to establish connections with all the other caps that you know about. And if you can't, now you're just sort of in server mode. And then maybe what we'll have to do on the UI is sort of give you the ability to say connect. So somebody initiates a connection to the other cap or something. I don't
okay.
know, but it's hard for you to see that because you haven't played with this yet. So
Yeah.
what we're gonna have to do is we're gonna write a little hack program where we've got a little client and a little server, and it can just do pings back and forth. So you can see how we can sort of establish a level 5. If you look at your OCI diagrams, remember in your OCI diagrams in school, 7 is application, 6 is
Yeah, yeah,
uh,
yeah.
I don't even remember. Let's just bring it up just in case. So that OCI sort of networking diagram, or the different layers,
It
OCI.
was the layers. Yeah.
Yeah, 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 yeah,
That
yeah,
one.
yeah, yeah.
That one.
So
Yes.
okay, so you see that diagram right here.
Yep.
So we're going to be coding at the session layer. Okay.
Got it. Okay.
This is where we're going to be coding. So TCP is your transport layer, IP is your session layer. We'll code at the session layer.
Got it.
The
Okay.
hardest thing about coding at the session layer is there's no guarantee um, on the data you're going to receive all the way up. So, in other words, I might send a paragraph of data. You're going to get that in chunks, right?
Hmm.
The chunks are going to be different every time you do that. There's no guarantee that you're going to get a certain number of bytes when the transport layer sort of calls you. So that's the hardest
Okay.
part about building these sort of socket level, session level protocols is knowing when a transmission is sort of done,
Got it. Okay.
right? It's kind of knowing when it's done. So when you send me something to know that I've gotten the entire thing, because it
Mm,
comes sort of in piecemeal. Like those are the big mistakes we make. So we're going to have to create our own sort of protocol. And the simplest protocol to have is you start off with maybe like a starting byte, like 0, and then you have sort of the length or the number of bytes that are supposed to come next. And then you read up to that number of bytes sort of in a loop because you don't know when they're all going to come in. And then when that
got it.
happens, our layer will then deliver the message up the call stack. And then you get the next one and you sort of deliver that up and you get the next one. And so we sort of can do it that way, right? So the application layer, presentation app, gets a complete sort of message,
Yeah.
doesn't
They
get it
don't
in
get the
piecemeal, right?
chunks. Yeah.
Well, we got to deal with that. So we need a little bit of a protocol. Now, early on in my Go career, I did some of this, and I didn't, like I always tell you, I don't know if I had a kit. Oh, I do. This is super old. Look at that. 10 years old, man.
Oh wow.
Yeah, yeah, yeah. There were, when I was first learning Go, I was taking things that I was doing in C sharp and rewriting them in Go as a
Okay.
way of learning Go. And one of them was, some of these are really bad now. Like I wouldn't do things like this anymore. But the TCP package was interesting because it can, leveraging some interfaces, um, it handled all the lower level stuff that I just talked to you about.
Yep.
And I assume it's still going to work. So the idea was that these handlers would get called um, when a network connection was established. I don't remember these things. We're going to have to look at the code, dude. But the request might be, yeah, data coming in, response. I don't know. We'll take a look. But
Yep.
the idea is that this took care of all the lower level stuff. So we're gonna have to. I'm gonna steal this code. We're gonna review it because it's been like a billion years, dude. I don't remember. Like I added like rate limiting in here too. That's insane. So we're gonna write some hack programs just to get this to sort of work after we review. I would even put money on it. Some of this code needs to be refactored because I wrote it like a billion years ago, right? Yeah. Now, I'm trying to think what would be the fastest sort of way to. I want the whole thing. I don't want to add a file. I'd love to just download this thing. Isn't there a way to not copy path? I mean, I can clone it too, but I thought there was. Isn't
You
there a
should be
way
able to
to?
just download a.
That's what I thought. I don't want to download the one file. I just thought I could just download the whole thing. Oh, maybe because it's a folder and not the whole kit. Okay. So maybe I'll just
Oh,
do this, man. I'll
yeah.
just
Okay,
clone this
there.
thing, right? Yeah,
And
yeah. Okay.
download. Or you
Let
can
me
clone.
just clone this thing. Uh, let me make a directory here. Just tap git clone.
The Git.
Yeah, it would help if I spelled it right. Right. Okay. So now that's there, right?
Yep.
So ideally, I guess the fastest way would be to, oops, I didn't mean to do that. Open up another new Finder window. This might be just the fastest way to do it, right? Got to deal with that DS file, but
Mm,
let's see, code, go, source, GitHub, Ardan, USDL Foundation. And then I have a little, I don't need you anymore. And then in here, I always have that find that goes through all the subfolders, deletes any DS store files. Because when you
okay.
use the Mac to copy, they create this DS store file. It's a freaking nightmare. Um, okay, we already had the code up. So what that now means is we've got sort of this code here. And like I
Got it.
said, it's been a billion years since I looked at any of this sort of code here. So I'm just going to take a look at it. I created my own error handler. There's the TCP. Look how I even used, like, I wouldn't do this anymore. The spaces in between
Yeah.
the different parts of the fields. Like, I wouldn't necessarily do that anymore. But you can see that I've embedded the config directly into the TCP struct.
Mm-hmm.
I gave this thing a name. It has an IP address, a port, a TCP address, listeners, so we can accept connections. Oh, look at this also. It already manages a set of clients.
Clients. Yeah.
So multiple clients can connect to this server. So look, that support's sort of already there. So that's kind of cool. Mutex for the map, a wait group probably for shutting down. And it looks like I probably do some load shedding for some of that. I bet you there's a better way to do that too. Okay. Some weird validate the configuration. I don't even know where this config is located. tcpconfig.go. Interesting. So finds handlers to provide events. This must be like for logging. And now we've got any for that, right? Um, that's definitely funny. I added rate limiting in there. So to validate the config that we're using one of those TCPs and that we've got handlers for the different sort of things that are going to happen. And then if we want to log, there's a logger there. Okay, that makes sense to me. Then I guess given a network type like TCP and an address, we're able to resolve that. and I'm storing all of that stuff. Now we have a TCP, and then we can start the listener. So this is old school Bill doing locks and unlocks in sort of a code block. So I wouldn't allow start to happen unless we had a listener already. Interesting. Which I don't see where t.listen is being set yet. Do you?
No.
No, neither do I. Huh, I don't see the red lines.
There's one
Oh,
there.
it's like this monitor I'm using is there. When I did the monitor and I told it to, oh, that's better. So there's got to be. Look at all this case scenario where I'm saying if it's nil.
Mm-hmm.
Ah, interesting. Oh, I'm saying if it's not nil, it was already started.
Yeah.
Okay, I bet you there's better ways to do all of this. Then I've got a wake group. I'm creating a go routine in a loop. This is a hard lock. If it's nil, now I'm establishing a listener.
Okay.
I don't know if I would do this like this anymore today. I'd probably do it as part of the new function, right?
Yep.
Um, establish a listener, say that we're done, log it, and then we're sort of out. So there's a loop here. And I might be doing this because if the listener fails, I want to be able to auto magically restart it. That's probably why this is here because networking things happen. And so
Okay.
if we get back to the top of the loop, we can reestablish a listener
Oh, okay.
because
I see.
now what's going to happen is we're going to be blocking here. So this is going to block waiting for a socket connection to come in. Look, I don't even
Mm.
use else clauses anymore, right?
Yep.
Once we establish a connection, I'm loading this integer here on the shutdown. If it equals 0, I'm logging something else. I'm resetting the listener to sort of nil, huh? I don't understand that code just yet. So load the shutdown. If it's 0, I don't even know what the error is. Oh, this is if there was an error on the accept. Okay.
Mm.
This is in positive path, right?
Yep.
Okay. So I'm trying to figure out why accept probably failed. Because
Okay.
we're blocking here, waiting for a socket connection. Now it returned. So if there's an error, I want to probably know if we were shutting down or not. Because if we were shutting down, then maybe that's fine.
Yeah.
And then resetting the listener back to nil. And then seeing if it's some other sort of temporary error. That's fair.
Mm.
So that's the negative path. And then as a continue, so we'd come back up and try to establish another listener.
Got it.
So
Okay.
that's going to fail. But assuming that that returned because life is good, check if we're being asked to drop all new. So we might be in a shutdown mode here, and we're just trying to shut everything down. We're not going to do rate limiting. And then I've got this function called join that it adds this network connection to something. And then that's the loop. So the majority of this code is trying to handle the fact that we might have an underlying networking issue and we've
Yep.
got to reestablish our listener. And hopefully none of this code is ever really executed. But the big thing when you're doing this level 5 networking stuff is you have to really be able to identify when client connections drop, identify when your accept stuff is failing so you can reestablish that and continue to sort of it's the hardest part in all this stuff.
Got it. Okay.
Now, the join, I'm sure we'll get to that. Oh, so I don't have to hide this anymore. I was looking everywhere where it was being used, so now I know. On stop, you could see here that we're basically setting the shutdown flag to true. We're then trying to close everything down. There's even better ways to do all this now. I'm not going to try to clean any of this code up right now. And then we're dropping all the connections and waiting. So we're trying to do a clean shutdown by going through all the connections that we know about and dropping them first before we do a complete and utter shutdown of the server. That is
Got it.
sort of
Okay.
super important here. Make a copy of all the connections. We need to do this since we have to lock the map and read it. So ideally what this code is doing, it's making a local copy of everything so that you can sort of range over it. And this is probably going to tell me that there's now there's a new map
Map.copy.
copy sort of
Mhm.
function, right? So I wouldn't want to make a single code change until we know this is working, because the last thing I want to do is break this and then
Yeah, now we're in a rabbit hole.
now I'm fighting that, right? So
Exactly.
there's definitely, we could spend a show like almost refactoring this, how we would potentially do it differently. So that's dropping a connection, which essentially means that we're taking it out of the map, I would imagine. Or, and look at that, I'm doing it asynchronously. I don't even know if I would do that anymore, right? This is
Mm.
10-year-old build code. Sending a response, send will deliver a response back to the client. So the send would be our server side sending some data. There it is. Who do you want to send it to? The data and the length.
Got it. Okay.
I wonder why I do length here when I could get the length from the slice.
Mm.
Hmm. We'll look more into that. This might be a certain. I may have decided. It would be interesting to see if I decided for memory purposes to create a buffer already of a certain size, so you can't trust it. We can see that, but this is like the interface side of things, so we have to code that. Here we could send a response to every client, so that's
Mm.
interesting. Dropping address, little things, stats about the service. Interesting. Groom, dude, I don't even remember writing this stuff here. Well, groom, dude, I
Oh,
totally do not remember writing. Drops connections that are not active for a specified duration. I guess if a message isn't sent in a certain amount of time.
yeah. It'll drop it, so it's not just holding there.
Oh my god, dude, I don't remember. I guess you get to
Oh.
call this yourself. Okay. I even have a test sort of thing here, but I'm not going to bring that in. See, that's bad. I had a tests package, right?
Mm.
So sort of bad bill. But this will let me also see how to use it. So given a config, new, start, this is the code we need to write our little hack
Yeah.
program.
Yep.
Then the client will dial in, set up buff.io for reader to extract a response.
Mm-hmm.
And then I can write a string. So this is interesting. I must get back an actual network connection. So I can read and write through the buff.io, send it, flush it, then read on that connection. This doesn't feel like, this feels like low level stuff here. Interesting. This feels like lower level stuff. Test TCP address, test dropping connections. I feel like this isn't even using Yeah, it's using TCP. See, it's not using our handlers here. This
Hmm.
test function is doing raw sort of buff IO. Interesting. I don't know why I would have written a test like this. I think the fun part is having these handlers here. Read, process, write, using a writer, using a, yeah. Yeah, I'm going to have to look for some sample for a second here. This doesn't feel right to me. Like, okay, great, start. Oh, but this is the client side, right? This would be client. This is what the client side's going to have to look like. So
Oh,
it looks
okay.
like my TCP is purely the server side of things.
Okay.
It's purely the server side of accepting connections and doing communication, where everything here is what we'll have to do on the client side.
Got it. Okay.
I
Okay.
think I have to look more at the docs here, but I have a feeling that the whole point of this package was to, yeah, accept client connections on a specified IP address and port, and provide support for sending data back. There are three interfaces. This interface is implemented by a user to bind a client connection. This interface is implemented by the user to implement the processing of request messages from the client. Read is provided an IP address, and a user-defined reader must return the data read off the wire in the length. Returning EOF or non-temporary will shut down. It's implemented by the user to implement the processing of the response messages to the client. So config, new, start.
Wait for shutdown.
Yeah. But again, I think the idea is I've got to implement this to know what's going on. We're just going to have to hack on something at this point. What's interesting to me is this, because what was I using this package for?
Reset log,
Test.
display log,
Why, man?
test
Dude,
update, success.
that is so silly. I probably was using this to do checkboxes and stuff.
Hmm.
There was a time in my life where I was using like some Unicode characters for like checkboxes and stuff just to make it look sort of pretty.
Okay.
And let's see here. Oops. I don't know what that was. Okay. Anyway, did it? There's one more ready. Red. Should have. I don't know what was there, but I don't really care, right? I'm just trying to get rid of
Yeah.
things right now. Stuff I would never do anymore, right? Okay. So you're fine there. Oh, and that's weird. Oh, because of the test. So that's not weird. I have to do this now, don't I?
Hmm.
Okay. That's because it's the. I put this in the test. Oh, I put this for the testing. Again, something I would not. Oh, there it is, underscore test.
Ah,
So it looks like from a test perspective, I see now what I did. This is the construction of these handlers.
okay.
So what I'm doing here now is establishing what we're going to do for reading and writing, a buff IO for reader and writer. And then here, what I'm doing is I'm reading until I get a carriage return line feed. That's my sort of end marker.
Got it. Okay.
That's interesting, which is something that we could still do in sort of the work that we're doing, right? We could look for a carriage return line feed as our sort of marker for
Okay.
messages, right? And then um, I don't know what process is doing other than ascend, but that's part of this. Uh, Part of the interface was process,
Got it. And
the
length
processing of the
is
message.
7.
I might have broken this up into two parts where it's like you read it and then you get it back like this, and then I'm just forming a response, right?
Mm-hmm.
I may have broken this up into a lower level sort of read and then a process, a higher level, right? Because this is sort of raw buffer data. And then this is all the information that we
Got it.
got
Okay.
back. That's the actual data and the length. That's my guess. And then writing was just about using our buffered write and our flush. So we're going to end up probably leveraging the same sort of code to do what we've got to do in our little hack program.
Got it.
And I'm
Okay.
down to, oh, it will be the same thing, won't it?
Yeah.
Okay. Okay. So my guess is I'm going to take this code inside of test and the handler test, and we're going to sort of reuse this in our little hack program. So I think if I copy and paste it, we'll see it a little bit more than
Okay.
what I've got sort of here. Okay, so tooling, this is our little hack program, right? The last hack program we did was sort of NAT stuff, didn't we?
Nats or the encryption? We did. I don't know if we got.
No, this is all NAT stuff.
I see RSA key on there.
So let me just save that. Okay, I know. Okay, so let's go back and look at this code here for a second. Man, it's amazing how old this is. So I'm going to let me steal all this for a second. Hit the wrong key. Let me steal this for a second. I'm going to put a big line here. So I know I've got to implement these things, right? That was part of what we had to do was to implement these things. So the lower level code just called into it. We didn't have to worry about the gritty details. So we're defining a type, which is an empty struct because we don't need any state. I just need to implement this bind function. And bind is basically asking us what type of reader and writer we want to use for the data. The buff IO is nice because it gives us the buffered IO, which for what we're doing, I think will be really good.
Okay.
Then when data comes in on a client connection, it's going to be two parts. It's going to be this lower level read. And so this is where we're trying to figure out if we've got a full message or not. This is where if we want to go with a more complex protocol like number of bytes and data, you have to assume that this is going to get called multiple times.
Okay.
So if you look at sort of this, read a small string to keep the code simple. Now, read string reads until the first occurrence of the delimiter, returning a string containing the data up to count as an error before the limit returns or returns EOF. Now, what's got me a little confused is read string returns. I feel like this might be a blocking call. So this is going to be interesting to me on how this works because, oh, it's against the buffer. I see. So this is going to be a read string reads until the first occurrence of delimiter in the input. So it's essentially reading this buffer, and it's
Mm,
essentially going to block until we get to the carriage return
yeah.
line feed or the buffer gets closed. And then it will return that information, right? Now, if I come back to the code here for a minute, this is the loop on the accept. So all this is doing is getting a connection and joining it to the system. And when we join that to the system, it's just part of that sort of slice. But my brain says that there should be also a go routine that's my brain says there should be a go routine now that's trying to listen for data on that socket connection. We're not doing any of this. We're not doing any of this. And I would have thought I saw it on join because all this is doing is it's saying new connection, great, accept it. Um, we're not shutting down, so just go and do your join. And all join is doing, I'm missing something here, I think. Then join is going ahead and saying validate that we haven't seen this IP
Yeah.
address
It's a
before.
new IP.
Ah, new client. So now
There
we
it
call
is.
new client. There it is. And new client now is establishing a client. We're checking. Look at this. Go routine read. I was
Yeah.
looking for that. So now you're in a go routine, and this go routine here is now waiting to receive some data. Okay.
Got it.
If there's an error, we check to see if it's a temporary error. We can go back and read more. If not, we shut down. We're splitting some IP information. This is the part I was looking for. Oh, it's reversed then. So we get some data. I construct a request. Then I call process.
Mm.
Okay. Then I called process.
And then process structures a response
That's
and
all it's
sends
doing.
it
It's
based on that
just
request. Okay. Alright.
saying I got it, which is fine, right? I said we were just going to do some pinging.
Yeah.
We'll put some logging in here. But that's still confusing to me because, as I told you, there is always a oh, here's the read. Wait for a message to arrive. Oh, oh, this is the read call that blocks. Okay, I understand how I did this now. So here's the go routine for the client, right?
Okay.
It's established a connection.
Hmm.
Now we're waiting for data to come in.
Yep.
So what we do is call read. Read is not allowed to return until it has a complete message.
Okay.
So this is where we might have to do some specialized processing around. Remember, because everything's coming in on the buffer,
So right
and we
now,
chose to use a buffer read. So now this blocks
okay.
because we've kept it simple. Thanks to Go, we kept it super simple. We could use a lower level reader and writer and this reader and writer could just be a raw socket connection. We could do some really sort of complicated things here. But the idea is that we don't return until we get a complete message, whatever that means in our system. In our case, a complete message is a string that has the carriage return line feed in it.
Okay. All right.
Okay. Then
Yeah.
once we get that information, we send that raw data out of the read call. We then take that raw data, combine it with all of this state that we know about with the connection, and then we say process the message. So
Okay.
I separated the code about trying to identify a complete message coming off the socket with the processing of that, because it is two separate things. We've
Yeah.
made this code simple because we're making the protocol simple.
Mm-hmm.
But if the protocol was a data length and wait for that number of bytes to come next, there would be a for loop in this function,
Got it. Okay.
reading small chunks of data as it's coming over the wire until we've identified that. And you might start to get parts of the next message. Dude, you have no idea how complex that is. But with the buff reader saying, read me to the /n, it's handling all of that because it's managing the buffer. We'd have to do our own buffer and then
Got it.
send a slice of that buffer to process. But if we keep it simple like this and say, read a string until you reach this delimiter, dude, that's why I love the Go team, right? Because they're doing this sort of hard, complex stuff for us. And then we get that. So this is beautiful, right? That's beautiful. And so you don't have to write all of this complicated sort of code, right? This is all sort of boilerplate stuff. You just
Yeah.
get the focus up here. And then this is the code that gets called underneath when we want to write a message back out. So this call here
Mm-hmm.
ends up calling through this. It's also funny that I didn't use context properly in here. Context should have been passed all the way through, right? So I think we're going to spend a show sort of cleaning this up. But you can see here, send is trying to find the socket connection based on the IP address in the pool. And then it's calling write, which is essentially this function here.
That. Yeah.
So I'm letting us control how data is buffered, read, and sent. And then the whole lookup of client connections and stuff, that's handled in this lower level sort of code here. And
Okay.
I think we could spend a show sort of looking at code that's 8 years old and Go and looking at how we would sort of do things today, right?
That would be cool just to see like an older way of doing things also
Yeah, right. I know code
and
works, so I want to make
recognize it.
sure it works.
Yeah.
But yeah, there's definitely like there should be a context here
Mm-hmm.
because I should be able to cancel on the context, right? Like all these calls should have a context associated with them,
Yeah.
all of them. And having a context in here, I don't know if that's the right thing to do. Like, why do I have a context in there? That's definitely not what we do. We don't put
I haven't
context as
seen. Yeah.
structs. No, dude. Like okay, but that's me like 8 to 10 years ago.
Yeah.
So let's maybe what we're gonna do is we're gonna get this. We're gonna double check that our hack program is working, and then maybe we should really just clean this code up as part of our software design
Mm-hmm.
sort of thingamajig here, because I think it would be a good show anyway, and I'd feel more comfortable with the code. Okay, so I understand that now. So now I can sort of steal some of this here. So let's come in. Oops. So I'm gonna need to do what I did here. Bring this in. Oops. I don't know why my keyboard brain's not working today. Okay. So just return. error for now. Oh, this is where I love the Copilot because I would have been too lazy right now to do that, right? So we're going to use our implementation of those interfaces, right? We can set that
Yep.
at 0 value. This means that we're listening on all interfaces, I think, our main interface, which is
Okay.
fine. We're going to create basically a new TCP server. So we've got that. Then just come
Start
here.
accepting data. Okay.
Then we're going to start the server. Dude, I don't know why my fingers are not on the right keyboard place. Is there a stop? Yeah, defer the stop. Okay. So now we're going to actually start. So that will establish the listener and allow us to essentially now accept client connections.
We got it.
Okay. So I'm going to put a line in the sand here. Now remember that all runs on separate Go routines. So now I'm going to use the raw net package APIs as the client. There's no reason to abstract that. So whatever the address was for our server, all right, I'm going to dial into that. We're using TCP 4, IP4.
Okay.
We're going to establish a socket connection. Now that I get back a connection, what we're going to do, thanks to the beauty of Go, is since that is a reader and a writer, we're going to wrap it around our buffered IO and leverage the standard libraries coding to handle data, buffered data, which is what we need on this
Yep.
TCP side of things. Okay, then what we're going to do is send a message to the server that says hello with our terminating carriage return line feed.
Yep.
Okay. And then we're going to. Now, I don't like this here. Ideally, what should have happened is this should get called and then process should get called,
Yeah.
right? Because the whole point here is, um, but this is where this starts to get confusing for me because I'm basically reading the response right here. I'm not using, this is where it all breaks down for me because on the bind, I already did these two things, right?
Mm-hmm.
On the bind, I already did these two things. So what's weird to me is I have the connection directly, but this U value did give us an API. Oh, but I'm not on the server side. Okay. Let's just do this. Oh, but I need to get the message back. That's for the, I keep forgetting this is the client side,
Mm.
right? This is the client
Yes.
side,
Yes. Yes.
right? So I need to get the message back. And the only way to get the message back is to sort of do the same thing on the client side. We're going to have this same code on both sides of our, though I think we're going to have to write some code to manage this as well. So we're expecting the server to send us this. Got
Yes.
it. Right.
Okay.
And that's what the response should see on the way back. It should see got it. And
Yeah. If the
what I
response
might
is not
just
here.
do is log the response, right? So we can use func.print response. Got it. But we need a log here too. So what I would say here is we could log this right here, right? So this is the server response. Okay, this is a client message, right? That's the client message. This is now one could argue that since this is the lower level one, that should be the client message. Just focus on process for a minute, right? So here's the client message. Then we can say server send that,
Okay.
right? Because there's the send. Um, yeah, I don't know why I'm doing this other than
Rate.
I was doing this for some testing, I think. We don't need, for what we're doing, we don't need it. So that would be client message in, server sending that, and then we should see the server response here, right? And this is just going to run one time. So
Okay.
idea is establish the server.
Yeah.
This is basically server side code, right? So now it runs that as a server that can accept socket connections. We start. Then on the client side, we're going to establish we dial into our server. Now we've got a client connection. We'll use the same buffered IO. We'll send a message, hello. We'll wait for the response, and then we'll get a response back.
Got it. Okay.
And we're using the carriage return line feed as our delimiter for the communication.
Yeah.
So what's going to happen is essentially, even here, we could say waiting on read, right? So that's the server side. Server waiting on read. That's the server. Just so we know what side of the fence we're on, right?
Yeah.
So waiting on read. Message read. Even if I just keep it like that, right? Waiting on read, message read, client message, send. That's on the server side. And then here's on the client side, right? And that's what we received. Okay. And let's put a send. And we know it's going to be hello, right? With the carriage return. Okay. Nice. So we should be able to run this. Now it's red somewhere. Did I break something on the NAT side? That stop. I must have lost a.
Nah.
Yeah.
Yeah.
Let me see. Why would that have happened? Huh. So it doesn't think we're using that anymore. Oh, because I called this NATS. NATS. Okay. Sorry. Now it makes sense. Okay. Now I've got some linter issues here. It's not going to like that. I've put a.
Oh, the slash in and the print line.
Yeah. And here we didn't handle the error. Okay. Oh, is there a con close? We should do that. Okay. Same thing here, huh? If you don't put that error in, you know what happens, right? That's where it fails.
Mm,
Okay, so no more
yep.
yellow. Um, and we have our hack program here, right there. Okay, so let's see what happens here. So none of that is good. Oh, there we go. So none of that is good. I don't like any of that. That should have been like really, really fast, right?
Should have been like, yeah.
Like blazing fast. So we definitely have some problems there. Um, Now the other problem could be that waiting on read uh, happened too fast, which is interesting to me because we weren't waiting on the read when the client did the send, right? Which is not good. So why this took so long, I don't know. The waiting on the read. See what I'm saying?
Oh, okay.
Like this should have been. Oh, that happens after the socket connection, is my guess. So I feel like
Client send hello.
it's
Client
like we're
send hello.
sending it, I think, before we can.
Yeah.
So let's just do this for now because I don't understand. And this is not the way to solve any problem. But let's just do this for a second. So something's broken anyway, right?
Yeah.
But that's okay because this is what we know right now, at least. Um, we know that we're waiting on the read. We were waiting for a carriage return line feed to happen. And oh, you know what I forgot to do?
Oh, the flush.
The
Yeah.
flush. Forgot the flush. Yeah. I didn't flush it, so it didn't sort of happen. Now, that might mean that I can get rid of this now. Yeah.
Read message read.
So it's all working, right? Like we've got code here now that when we use the buff IO and we have a delimiter, which for our chat system is fine because we don't do extra carriage return line feeds in the messages, that we'll have to make sure there's one at the end. We could use any delimiter, but the one carriage return line feed is going to be fine, right? But any delimiter will work. But I think that one's going to be fine. Just simplifies things tremendously.
Yeah.
So let me at least save this code here for a second. Okay, git commit minus.
And why
We
is
have
it that
our
the without the flush it didn't like complete?
because it was never actually written over the socket without the flush because it's buff IO. So there's probably a certain amount of data in the buffer that has to be there before it auto magically sends it,
Oh,
and
okay.
we're well under that, right? So
Mm-hmm.
um, if we looked at return, if the count is less than length, it also return. But if we dug into this a little bit, it's buffered IO. So the question is like, when does it decide to flush it as well? Like here's a flush right here. So if it 0 and whatever this try string writer thing is, right? Then
Yeah.
it did an automatic sort of flush. So that's part of the buffered IO stuff here.
Got it. Okay.
Written into it. So if there's no bytes and try string writer, large write, empty buffer, the underlying writer supports, right? Yeah, dude, I don't know. But we need the flush there to force it to be actually sent.
Got it.
That's the
Okay.
read. In fact, I don't see it ever being written until you call flush. Interesting, right?
Hmm.
Yeah. Yeah. So whatever. We just have to do that to send it over the wire. And then it will handle the chunks and everything for us automatically, which is beautiful. Yeah, I remember that
Yeah.
now. In C sharp, this was so much harder. Okay. So I just pushed that, right? We now have the ability to establish a peer to peer connection. The cap is going to have to act both as a server and a client.
Okay.
We have no client management, which I thought for a long minute. I think there's another reason why I was confused. I thought the TCP, I have one for UDP too. I thought the TCP also handled client management, but it's not. It's only handling server management. So
Okay.
we're going to have to do some client management. In other words, our cap might need to connect to more than one other cap,
Okay.
you know.
Uh,
Uh, but that's not a problem I need to solve right now. But my brain is sort of chewing on the idea that even though they all act as servers, somebody has to initiate some sort of client connection. And you saw this is two-way communication, right?
yeah.
Now, we could make it so both sides connect and we do it that way instead of doing sort of duplex on the one connection, which I don't really like, to be honest with you. I mean, the whole point is that we can have one socket connection and talk to each other. There's some things there that I have to think about because it's always been one way for me in my entire programming career. One's a server and one's a client. And now
Hmm.
you have a situation where um, the cap acts as both a server
And client.
and a
Yeah.
and a client, right? Somebody's got to establish a socket connection somewhere.
Uh-huh.
So again, one thing is that all caps have to establish a client connection to the other cap, and actually, that's not a bad idea. That would be the way to do it. That you establish client connections to all the caps, and then your messages, right? If you're a client, then the idea
Okay.
is that your initiate on that client server connection, and the other one establishes. So when you hit send, you're using your client connection to that cap. When I hit
Yeah.
send, I'm using my client connection to your cap.
Yeah.
Problem
Yep.
solved, right? So everybody is both a client and a server
It
in
just
that
depends
case.
who's sending the message and who's receiving the
Yeah,
message.
yeah. A send needs to. So all caps are going to establish client connections, which are going to interact with those sort of sends. Then it's nice and simple in terms of, yeah, actually, it really has to be done that way uh, for some reasonable. Yeah. Okay. So that problem goes away. But though we have management in here already for accepting connections, we don't have any management for establishing sort of different connections. We're going to need something in our code at some point because you might connect to like 10 caps for
Yeah.
10 different people that you're sort of talking to. There has to be some management around that. And that's why you see in the sort of API, the on a send, it says who you're sending it to. And then we're looking up a map of sort of client connections. And then we know basically where that actually established socket connection is. So you don't have to worry about that. Like we do it on an IP TCP IP lookup.
Okay.
Okay. So we know this code's working now. And there's stuff in here that rate limiting and stuff that I don't need and maybe some other things here. And the event, I'm surprised on new config.
The
Yeah.
event.
You remember there's an event handler, so you can get some
Yeah.
logging, right? T
Yeah.
dot event. And I don't see,
I thought I saw it in config.
yeah, I hit it in config. This is all bad stuff I would never do ever again.
Yeah, up
And
to
the config is, oh, even that's confusing.
hmm.
Like I wouldn't name it like this anymore, would I?
Yeah, you don't do the underscores
No.
unless it's test now.
Yeah. And I was playing at the time at this naming convention called opt to suggest it was optional,
Okay.
right? But you can see that doesn't really sort of work because it would be nice to have some lower level. So, like if we look at opt again for a second, it's a function. I know we're going to clean all this code up, right? But it's a function that yeah, it's funny that it did this,
Yeah, that's weird.
right? Yeah, somebody must have done that at one point. But like I don't even remember what UVT and type is, right? Format interface. So the funny thing here is this probably was meant to be in a fumpt.sprintf, right? I never remember what side the dots were supposed to be on. Obviously, it's not that side. Dude, what's that dinging, man?
Can you hear that? Okay.
Yeah.
Get some.
Ops event is F. The ops event is supposed to be a function that is an ops event a function that takes on that. Is this a function? Cannot use F, incompatible assignment. Hmm, that's weird. That is weird to me. Oh, a struct that has a function. Damn it. Sorry. See, I wouldn't do it this way either. We're going to fix these things. Like Bill would just pass the function in, not a struct with a function, right?
Yeah.
Uh, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Yeah. So now if I run it like with this, yeah, I've got some new. Now I've got logging,
New
right?
connection ready. Okay. And then connection drop, shutdown. Okay.
And I don't know what these types are. I'm sure there's a whole, event types,
When you're using
which is
error.
fine,
Okay.
but without a map, right? Like logging that doesn't make your life any better because I don't know which one is which,
Yeah, unless
right?
you're looking at it there.
So we need a map that sort of maps that stuff so we can so so these numbers mean something to us on logging. Okay. All right, that's fine. That's fair. All right, let's push this too. So just add it. So what time is it? It's
12:15.
12:15. Perfect. Okay. let's spend the rest of the time seeing if we can clean up this 10-year-old code.
Yeah.
Because there's some stuff here that I don't think I would do anymore. And I'd love to sort of
I think it'll help us
clean.
better understand it also.
Yeah. So, like this struct here, right? I almost feel like I don't know, what am I doing? Right? And even this, right?
Okay.
This is our event func, right? So bare minimal. Um, now I have no idea how this actually works. It's almost like done at a time perspective, right? So like this alone already to me is much better.
Yeah.
Right? And
Yeah.
checking to see if it's null or not is fine. And then in here, there's a rate limit function, right? Much better. Nothing else there. And then here, check if rate limit is enabled, right? If the function's not null,
Yeah.
then this will only accept one connection per duration. Oh, so it's a rate limit for connections.
How many connections?
So if I come back to where we did that, is used to set a rate limit for accepting new connections, right? That way somebody's trying to like establish a shitload of connections at one time where we're going to rate limit sort of that. Normally when you think about rate limiting, I didn't think of it at the connection level. I was thinking as even at the message level, right?
Okay.
So I would almost now want to change this to, even though it's a long name, that's fine for now, right?
Connection or con.
Yeah. Just for now. And I would rename this file to just config if that's what it is, right?
Yep.
And you see how I did embedding here?
Yep.
Like I wouldn't do that ever again. Like, and
You would
even
do it
this,
like that. Okay.
like I would even just call this the logger, right? sort of like that.
Okay.
And a lot of times I don't even like using the word function if I can sort of get rid of it. You know, and this whole idea of screaming that, who cares? So for sure. Now, let's take a look at this for a minute though. So this is now logger, right?
Yep.
Or actually,
Or
it's called log,
log. Yeah.
which is better. That's all right. Let's even just call this just for logging, right? Whatever goes right, I don't really care.
Yep.
Okay. Right. Now it's complaining because I have a method that's named the same thing here. So what have I called it logger here for now? Now that's fine, right? I want this to be called log. My problem though is I don't want this at the config level. The validate I'm okay with, but I really don't want this function here. So let's go and do the following for a second. I don't care about that for a minute. I don't like this. In fact, I want to know why we're even keeping that information. Because what I'd rather do, is that, let's get rid of, now that I made exported for some reason. So let's do this for a minute. Let's say I did that. Okay. I'm going to fix this too.
Yep.
Then ideally, this log can be CFG log, right?
Yep.
Okay.
Instead of the entire config, we just need the log portion.
Yeah, and it should be lowercase. So anywhere that we were calling event, it just feels better, doesn't it? I don't know what's wrong with that just yet, but we're going to fix all that. This just feels better in general. Okay. Now, somehow I broke. Oh, okay. This is why I was looking at this. So I don't like what I did there. Like, if I need these things, right, then I should be sort of protecting that. This is a much better, right, way to do it. I mean, I understood why I did it before, but ideally, this is much better. And then after log here,
And it's better because it's more like explicit that we need those rather than like
yeah,
hiding them and
because why am I mean, I've exported all that data. It is a copy, but at the end of the day, it's like it's not a good API design to expose config. It was fast, it was
yeah.
sort of easy, but it wasn't really a see, even net type, address, all this stuff really. If I needed all this stuff, then it should have been sort of in here. And it should then be
Okay.
and then you have this sort of rate limit as part of the config, right? So let's just say I put it here. So for sure, to me, this is better because now we're not like sort of exporting it or exposing it in any, like I would never, what I did back then was fine because I was trying to implement try, like do not repeat yourself in a sense.
Yeah.
But it's not a clean API at any level. This is much cleaner. The fact that this needs this much config is what it is, right?
Mm-hmm.
Okay. Fix this one in a second, but my guess is it's just a matter of okay. And then on the config side now, right? It's a logger, which takes an F. And that's what I was trying to do from the beginning, right?
Mm.
Because that's how I do everything. It's just, hey, you need a function. Here's the function, right? It's not anything more than that. Now, ideally, this should be a string here. We're going to fix that since there should be a map that gives us at the log what it is, not the number.
Yeah.
All right. So, I mean, that's stuff that we've got to fix. But I want to do a little bit here at a time. So, from a config perspective, right? I've got the connection rate limit function, the logger. We've got all this, right? Support for binding new connections to a reader and writer, support for handling specific request workflow, right? If we just want to be, I usually don't like going over this gutter, but that is what that is.
Yeah.
You see, now I want to get rid of this altogether because the validate is fine, right? You want to do some, in fact, I've never done this again in my life, but I don't think this is necessarily a bad idea, right? And I think even just to make it a little cleaner, now I'm using these error variables in here, but I've sort of put them up here. That's a mistake to me because they're all being used sort of here, I think.
Yeah.
I think.
I think that would be easier to kind of understand.
Yeah, I mean, if we're going to do it. So I'm going to force that you have a logger, right? Also, I don't know why this is exported. I mean, why is that exported? Second of all, why am I using pointer semantics? Right? I mean, we should not be using pointer semantics for this. This is config. That's the other problem. Some inconsistency in all config should be value semantics. We shouldn't be sharing it. Like that's where you get into a lot of trouble.
Okay. Okay.
So I'm expecting this and then the validate. We're the one calling validate, nobody else. So why is that exported, right?
Okay. Because we're doing config. Yeah.
Now, in the config, we called it logger. It's fine. And here we just called it our log. That's fine. So from a config perspective, there was one of these. I'm not using that one. I'm using that one. I thought I saw something go red in tcp.go. No, okay, good. Okay, so these errors are being used here. These are our types, right? And validate should never have been exported. We're only using it internally just to validate some things here, which is an interesting idea that I've just stopped kind of doing. I just assume that somebody's gonna give me and for projects I think it's okay, but for these potentially third-party packages, it's probably not a bad idea to have a validate method
And
against it.
make sure you have
Yeah,
that's essentially
certain things.
validating that someone's using every option in that config
In this case,
or
we
every key.
expect this. We can't run without it. In
Yeah.
this case, what is the better way to do this, though, Kevin? It'd be better to use a strong type than a weak type here. So when I
Okay.
see something like this in production code, I would argue that maybe we should have a
Or
strong
TCP
type
type,
here.
like making a
Maybe a net
TCP type
type, a
rather
net
than
type.
or a net type rather than a string.
Yeah.
Okay.
Yeah. Because if it's a set and we use a strong type, I don't have to write that if statement. It can't be, right? They'd use a parse function for
Yeah.
it. And so this is a candidate for a strong type.
Mm.
But if this is required, like you're not allowed to function without these things, then these checks are pretty good. Okay. So let's go back to TCP for a second. Now, like I said here, these are event types, right? And subtypes. And it would be nice, I think, in Bill's modern world today. I'm going to add a model.go. I want to take this stuff out of here and bring the TCP type right to the top. I think there's value in your TCP.go where you see as close as almost as quick as possible the TCP type itself, right?
Mm-hmm.
And having the model, I think, is fine. Now, you know me, I would start to do things like this just to separate it. Now, I called this a client error, right? Um, I don't know if there's anything really wrong with just calling it an error. You know, we call it, do something like this. Like, why call it a client error? It's the only error that we have. What's
Okay.
also interesting here is that this has to write implementation of the error interface. This is our error. It's the only error we have. I'm creating a bytes buffer and I go through the collection of potential errors. So normally then I would have called it errors, right?
Mm.
Since it's a slice.
Yeah.
And then we're just listing them out with a carriage return line feed. Okay, that's fine, whatever, right? But we have this idea of a collection of errors. So I think that's a little cleaner. How we want to print them out is, right? We could even just marshal that to JSON if we wanted to, but that's fine for that. This is what's bothering me a little bit because I think it would be nice, right? God, dude,
I think
I
that's
love
much better.
Copilot, man. That would have taken me a few minutes, right, to do. Like that's like badass, right? And the reason I'm saying this is if we come back to our config for a second, right? Now this can be a string.
your logging becomes a lot clearer.
Right? And then we
Rather
do
than
the
just
following. You see, because now I would do the following in here. I'd write a function now. Come back here for a second. I need a function that implements this. All right. And I would want this to be what's getting called. And this would take the ints. So watch. And then what we do here, and I already said that I'm going to force that we have it. See, now these can be S's, and this could be the map lookup for event types, right?
event types. Okay. Event subtypes. Yeah.
And then now we got to fix log to be this instead. So sort of that. Yeah. So we're asking the caller for a function. Actually, this is wrong here. This has to be cfg.logger,
Okay.
which takes this. Sorry. So we're going to stick with the integers. But when we call the user's logger function, we'll convert those ints to the strings and make the call that way.
Got it. Okay.
Right. And what that now means that our internal logging function has to look like this, which is fine. Right. The exported one is the strings. We have an internal one that takes ints. So we can pass the constants in. These constants that we've defined. But the caller will get the strings. So assuming I didn't break anything major anymore. Right. Assuming I didn't break anything major. Now we know accept info, join trigger, read trigger.
Yeah, much
right?
better.
Yeah.
A lot
So we got that.
clearer.
Yeah, we got that for free now, right? Because I had no idea what those were before.
Yeah.
Right. Okay. So, and now config is sort of taken out of this completely. We now have sort of what we need for all this stuff. It's a very big API, isn't it?
Yeah.
Yeah. Yeah. Now, I think it might be better to maybe organize it this way. I like to put the config first in a struct. Gives me a general sense of sort of what we're asking for and then what we sort of need, like internally what we're going to need. Now,
Okay.
again, I don't like the name being exposed here the way we did it. So if the name is needed, let's see where it's needed, if any. Let's say somebody needed the name. This is sort of where I would just write the getter in a sense. But I'd call it name.
And return t.name. Okay.
Yeah. This is the idea where you might have multiple of these and you're just naming it for logging or something
Got it.
for logging purposes. Um, Now, you also know that I like to have all the exported APIs first.
At the
And
top.
that was a function anyway. That wasn't even a method, right? This was some function I wrote. And to me, this is an over abstraction. So let's take that, see where things go red. Like, why are we not just doing this? You know what I'm saying?
Yeah.
Like, why did I write a function to make that smaller? Why? Because of the iota stuff? I mean, I just got rid of a function that I didn't necessarily need.
Yeah. It's
Like the
only
net
adding
package
those
already gave it
tokens.
to me,
Yeah.
right? So, and everything else is, so look, I just got rid of that function. Like, I don't
Yep.
think that was a big deal. Okay. So we've got the new, we got rid of that config state. So I think this is much cleaner. We've defined these two types. That's fine. I think the new is better. We've got name, we have start. Now, let's talk about all the locking and unlocking and stuff that's going on in here. I would say the API in general is right. I don't think we ought to change the API. But what am I trying to do here? I'm trying to say that if we already have a listener established, I want this sort of to fail.
Yeah.
But I can't. So this is funny that I'm using a lock here because technically this is a read, it's not a write. And then I'm unlocking it very, very quickly. So this listener mutex really should be a read write
A
mutex.
read. Yeah.
Start there for like at bare minimum, because this could be a read lock, this could be a read unlock, and then you'd have the read unlock here to return at a bare minimum. Okay,
And what's the
because that's
difference between having it like a normal, how it was before, like normal lock and unlock?
it's probably not a big deal on this code because you're calling start once.
Okay.
But if you're going to have a lot of reads, which I'm sure we are later on in this code,
Mm-hmm.
taking an exclusive lock means that all other code paths, even if they just want to do a read, has to wait.
Oh,
It's
okay.
like it's like you want to go check your score, but you're
Mm-hmm.
not allowed to check the score until the 10 people in front of you check their score.
Oh, okay.
That's
Got it.
bullshit. You should be able to go right up to the board and
Yeah.
look. It doesn't affect the person next to you if you
Got it.
read your score. And I kind of put them in line there, and I think we're going to see this again.
Mm,
Now, I don't like the pattern here that we had to do this. At the same time, um, you can't do a defer here because you can only be in one lock at a time.
got it.
So what I would do here and make this an unexported function, okay, um, is maybe
Separate, separate them.
if we needed the listener,
Listen.
which is this, right? Then what we could do is a read lock, sort of defer
Yep.
read unlock, and then return the t.listener. So let's say I put this, and it wouldn't be capital, it would be lowercase for a second. And the field's already called listener, right? So
Mm,
um, let's just call it accept listener for, or TCP listener, fine. Okay. See, now how does all this change? Well, now what happens is I could say listener this,
TCP.
right? Oh, T dot, sorry.
Yep.
Okay. Much cleaner, right?
Yeah.
I'm doing the read lock on that, read unlock, and I'm bringing it back, and then I'm storing that pointer in a local variable. That's fine, right? And I now have a pointer to the listener. But if it came back not nil, then but ideally we want it should come back nil, right? So I could argue this. We're expecting it to
Okay.
be nil. We're expecting it to be nil.
Yeah.
So there's no reason to even apply a local variable to it yet.
Got it. Okay.
Now, we need to wait for the go routine we were about to create to initialize itself. So I created a wait group, wait start, I called it. Then we have another wait group at the TCP level. Okay. So we've got a wait group at the TCP, and this is probably managing go routines, is my guess. This go routine. So let's see what I did here. Start to accept, start the connection to accept a go routine. And this is probably so we can shut it down cleanly, right?
Yeah.
So maybe what we'll do is wait group accept for now. Okay. Okay. So let's see what happens. We start the go routine. I declare a local variable set to its 0 value. Now we go into an exclusive lock, start a listener for the specified address and port if one does not exist. So we're back to this now, right?
Okay.
Now, here's the problem. I think this is why I got out of the lock. We're in a lock, so I could read that directly. And the point here is I'm in the lock, so this call is serialized. It's not a matter of reading it now. If it is nil, then we have to hold from somebody coming in behind us performing this operation.
Mm.
So this is interesting. I don't know why I didn't do this, but maybe with the other code cleanup, I can do that now, right? This is a new variable.
Okay.
Now I'm probably calling panic here because I'm inside of a go routine and I didn't create a clean way of handling that. So we'll get back to that in a little bit. I don't like that. There's going to be better ways to do that. Now, if we're able to establish it, I save the pointer. I call done and log and get out of this thing. And that's all there just because we don't want this function to return until this go routine is in a place to be able to accept connections.
Okay.
But I think this is a bad place to do that because it's not really until here that it actually happens, right? So the
Mm,
general pattern, yeah. See, we're doing the done here. And now we're blocked, waiting. So for my brain right now,
yep.
that's really when we should be able to report that we're done because we've gotten that far, right?
We've
We
logged
now
in
have a
on that.
listener,
Yeah.
a proper listener. Now we're using the local listener too, even though we're keeping a reference to it, which is fine. That's a little bit shaky ground for me. But at the same time, we don't want to be in a read lock while we're stuck on the accept. So I think we're fine there. My question is, how do I sort of clean this code up? Right, we're trying to establish a connection here. So again, I think
Move it out.
my brain says um, start a listener, right? Where I think you're returning a listener. And I'm just going to steal that code for a minute. We're going to clean this up. So I think this is obvious already, right?
Yeah.
Okay. We're going to go into a lock here. Now, the question then is, do we care about that check? Can we just assume at this point that if we're calling it, it's because we need it? See, and now I'm going to do this,
Instead of a panic, return error.
at least there. And now we're still going to set the listener, right?
Yep.
Because, or do we? Maybe we don't do that here. Okay, we do that. Now, what that would mean to me then is I also don't need this, but I'm trying to get the mutex stuff out of the other code.
Yeah.
So I think that to get the mutex stuff out of the other code, we have to do that. Like this part, because then I wouldn't
Oh,
need this at all.
okay.
And that's not saving my life at all. Because now what I want to do is this. I want to come in here and say,
But it's
what did I call that?
a start. Yeah.
And that's much cleaner, right?
Yeah. Much cleaner.
Now it sets this local variable here, which I want to understand more because I don't understand where this is being used 100%. Like it's being used in this force loop. You know what I'm saying?
Mm.
So part of me says, let's play this out here. Oops, I just destroyed my background there. Still good? Okay.
Yeah. Good.
So by having this little function, right, to isolate the mutex, this code starts to clean up a little bit, even though it's storing that state. So we validate if we have a listener or not. we start our wait group to make sure that we don't do anything until this is ready. Though it also is kind of silly in the sense that we could drop the listener and still have to function, right? Waiting to make sure that I don't know how important it is to have to wait for that go routine to be 100% ready. Because even if it's not, right, it's failing for some reason and we correct it, it's going to go back and start to accept connections again. We just have to log what's happening. So my point here is I don't think we need to worry about waiting for this to actually have worked. We could just get the go routine going and move on.
Okay.
Because if it fails, like we're not waiting again. Now, I will I'm going to get rid of this. Yeah. So event type info error, right? Just for now. I really would like to get rid of the panic, but this is essentially saying that we can't accept socket connections anymore. You basically need to restart the server at this point. So we'll have to get back to it. So start the TCP listener. Now we I want to try to get rid of comments too that I just don't think add value. We know what this is for. Okay, now, if this fails, we're setting a flag called shutdown. I'm using integers so I can use these atomic instructions to minimize the data races.
Okay.
Okay. So we're loading the value of the shutdown into a local variable. If it's 0, in other words, we're not being asked to shut down.
Yeah.
My guess is the stop code sets the shutdown flag to 1. You see that?
Yeah.
So if we're not, and you know me already with this thing, right? Switch,
Yep. Switch the
shutdown, case 0, default. Okay. Okay, we'll look at this. So 0, which means that we're not shutting down. We're just going to log it.
Yep.
Else we are shutting down. And it looks like I want to set the listener to nil and then break out of this loop. All right. That requires us to do a mutex here, doesn't it? So what I would do then,
let's do a stop.
Unfortunately,
Set.
And really it's just a nil, right? We're never setting it to anything other than nil here, right?
And we're doing this because of the mutexes, or to get them.
I'm trying to clean that up as much as I can, right? Now, the bad part about the switch case here is that we're looking to break out of the 4. So I could do a couple things here for now. This is like a glorified go-to. So when you're in a situation where you're inside of a statement, like a switch case, that has a break, but you're not looking to break out of the switch. I'm looking to break out of the 4. I could say break to that label.
Oh, okay.
Now,
I haven't
it
seen that.
feels a tiny bit of a smell, so we'll look at it a little more, but I don't want to use the else. And it's interesting, right?
Yeah.
Somebody watching this will be screaming go to like you're doing a go to. Technically I am, right? I'm breaking and go to that sort of break. But let's just keep this for a minute. So we've got the start, like we don't want that to happen. Now we do an accept. If it fails, we check the shutdown. I could also almost argue that I don't even need the shutdown variable, do I? Right?
Mm, yeah.
Now, if we're not shutting down, right, I've logged this. But here's something that's interesting. I want to log this anyway. I think what we could do, if it doesn't equal 0, right? I don't need this anymore. You see? Because I needed to log it anyway. So deciding to log or not was irrelevant because if this is true, we're getting out of Dodge anyway,
Yeah. Okay.
right?
Yeah.
So we load it. If it's not 0, that means we were shutting down. Reset the listener, drop out. Now log it. So I just got rid of the break label. 99 out of 100 times you can usually get rid of it at some point when you start looking. Now,
Mm,
the network package has a temporary interface. You're really supposed to look to see if the error implements it and calls it. If it's temporary, you don't have to worry about anything. You can just sort of continue on.
okay.
If it's not temporary, then you have a massive problem and you sort of have to get out of Dodge. So, or
Gotcha.
restart it, which is really
Okay.
what's happening here, right? We're sort of restarting it.
Yeah.
So, what I would do again is to clean this up. This point here is to get back to start, right? So this sets it calls it nil, doesn't it? Reset. So maybe what we really want to do here is that. We already have the reset, don't we?
Yeah. Okay. Let me do that instead of that. Yeah.
And then we go back to the top of the for loop because we have to start the process over. So how much cleaner is this, man?
This is much easier to follow.
All because we're adding little support functions to handle the
Yeah.
I'm going to move this stuff down eventually, right? But
a-
to handle the state issues.
And just the naming of those little functions also helps a lot in understanding what's going on.
Now, this is a mistake having the log here because it's going to hold the lock longer.
Mm, okay.
So ideally, we want this out of here and we want that here. We don't need it in this is a mistake that you'll make. Anything you do in here is going to hold the lock longer than, right? So we want to do the bare minimum
Yeah.
here.
Just in what we
Now,
need.
I would argue too that we don't even need to hold the lock until we know that this works
Okay.
because we're trying to set it here, right?
Yeah.
Now, I don't think it mattered too much because if we're in a start situation, it means we're in a pretty bad place anyway, and nobody should even be trying to read. And so I think it works to our advantage to just put it up. But sometimes I would have looked at that and said, whoa, 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 whoa. We don't need the lock until we get to 103. So why are we holding it before? In this case, I think it adds value to hold it before because we're trying to get the listener working, and nothing else works anyway until you have it. So you might as well make everybody wait until you know these two steps are working.
Got it.
Okay. So this is much cleaner now, right? We start the TCP listener, then we can accept connections. If that fails, we have choices here. If we're shutting down, we just go. If it's a temporary, then if it's not temporary, then we reset it and then we continue and try to do it again. We don't have to reset it if it's a temporary error.
Got it.
Now, at this point, we've got a socket connection, right?
Yep.
Now, there may be a case where we're trying to shut down while this connection came in.
Okay.
So ask if we're being asked to drop all new connections, right? So, or somebody may have turned a dial and said, or rate limiting might have said, no more,
Mm.
something.
Yeah.
So we're going to check to see if we're even allowed to have it. And if not, we just drop it. So that's fine. And it's not even rate limiting. It looks like I've got a dial there that we can turn on and off to determine whether or not we drop connections or not. Now, I don't know how that ever gets reset. There's a function. So there's an API there that allows you to sort of do that for whatever reason, right? It's there.
Yeah.
Then you got the rate limiting. Only accept one connection per the duration. So that's all clean, right? And then I marked the last time that some stats. That's fine. Then we added this connection to this other thing that we're doing. Um, and then this is the loop. And if at any time we break out of the loop, I call this done. Now, I think this doesn't belong here. Bill would always have done it like this. New Bill
Defer.
would have done this. Right? This is cleaner, right? This is new Bill would have said, okay, no problem. We'll do that. Maybe I'll do the log first, just so we get it first, right? So we're doing a shutdown, and then we will communicate that the accept handler is down. In the meantime, we just return once we hit start, and hopefully we get a connection established. So nice, right? This is
Yeah.
nice. Let's double check that this sort of code change still works. Ba boom ba.
Aha.
Blew up there, right? On line 64 to 28. So on line 64 now, the dial. Interesting, the dial. Invalid memory address or nil pointer. Now that's super interesting to me that this is happening here and not happening in here. Huh. Oh, I would say the logging blew up somehow. So, no, the logging didn't blow up, except error. It went into a shutdown mode immediately, didn't it? Okay,
It,
so we got waiting. We got this far, right?
yeah.
And then the next thing I saw was accept error.
It was
this. So the go routine terminated, except error port. Got no IP address. I got no port. Interesting. Shut down. So the question is, interesting, right? So we were here, and then we ended up being here.
Mm.
So maybe this logic was off or something. So let's do the following. Let's just see something here. Okay.
It's in there.
That logic might be reversed, right? Okay. So we asked to load the shutdown. Shutdown should have been 0. So now we need to see what this value is, right? Well, I guess we know it's not 0. That's weird. What happened?
Invalid.
Yeah, but why am I not seeing? I'm not seeing even this anymore. Oh, hold on. It's weird, right?
Yeah. Valid memory address.
I don't know what's happening. Something weird is happening.
Oh, there it is. Hit 6.
1, 2, 3. Yeah. Things are dying faster than I want right now. We know this happened. We know this happened. And the value of shutdown is 1.
One.
Okay. So here's the question.
So the logic is right.
Or not. We're going to look and get rid of all these stars here. Okay. So hold on a second here. The shutdown variable has to start at 0 because we don't do anything with it. So the question is, when does t.shutdown get set to 1? It gets set to 1 on the call only to stop. Now I'm doing a defer stop here, right? Okay. Okay, fine. Stop was called. We haven't even gotten to that code yet. Obviously, this defer is calling it. This has always confused me, not wrapping that around. I'm really confused, bro. Like
Yeah.
ridiculously confused. Okay, so for some reason, this program is calling stop. I'm so confused, dude. We obviously broke something.
57. Yeah.
Um, obviously broke something. This dial might be failing. Hmm. No, I don't know, bro. I mean, we're kind of out of time, but something's causing stop to get called, and I'm not seeing an error getting called here, right? Because we've got the error here. This is not happening. Whatever. Dial calling stop. So you see, something's happening from when we call dial. Oh, the whole thing might be just panicking too. Okay. Something's happening in here. For some reason, the shutdown variable is, I don't know why. Let's just log it, right?
Yeah.
Man,
Um. hmm,
yeah, the shutdown variable is,
Calling stop.
we're not even getting there. The thing is happening so fast that we're not even seeing. You know, remember when I was waiting for this? The code I took out was waiting for the accept handler to be ready. And now that's no longer ready. So, what might be happening, since I'm not waiting for the
Yeah.
accept handler now, right? Is that, well, probably what's happening um, is when I took that out to say don't move on from start until we know we have an accept handler. That's probably what's causing all the pain. Yep.
Yep.
Okay. So let's do the following. I'm going to put this back. Put this back. I know what the problem is now. But it shouldn't be a problem. Like, this shouldn't have been our problem.
Hmm.
What should happen here is essentially see, I would argue that we were somewhat cheating.
Okay.
Okay, let's see. You see, what's weird to me, it accepted it, right?
Except waiting and then immediately shut down.
Like I shouldn't. It accepted it. At the end of the day, I saw, well, it just started the listener, and then we were accept info waiting, right? So this is like waiting for connection. So that has nothing to do with it. Then once the connection came in, what I don't understand is this. What I don't understand is this. Why this shutdown? Yeah, I'm really confused. But we're totally out of time here.
Yeah.
So it shouldn't have mattered that I was waiting for that. It shouldn't have mattered. This is going to be a really stupid thing once we find it, right? The the bad part here is that I don't know. Yeah. Something's causing the go routine to, and we know that it's somewhere within here, right? Yeah. Okay. I do not know why stop is being called. Yeah, I don't know why. I'm gonna have to look at this later. This is really I honestly have no idea why. Like zero idea why that's getting called. If you notice, we see the connection one,
Yeah.
then this is why you don't want to panic. I don't think that panic is what's doing it. You see, something's causing this to shut down. I don't know what it is. Oh, I know. Well, I know what it is. It's this, at least for now. But even if I get rid of this, the funny thing is that when the client connection is accepted, there's an error, right? And I can't get to it without.
Could it be because of the? Well, we need to use the address of T dot shutting down there, right?
Did I
Original.
use of closed network connection? It's as if use of closed network connection. It's as if we dial up I I'm I am so like confused. Use of closed network connection. It's almost as if the listener's already done because we called stop. Yeah, I don't know. All right. I'm going to leave this code here. I'm not going to push it.
Okay.
Jimmy says he knows what it is, but I don't know what it is. There's some weird sort of data race or something. Ever since I got rid of that code that waits for the accept handler to be sort of properly established before we start accepting connections. But my problem is that later on in life we could get back to this same place, you know.
Yeah.
And but Jimmy knows what it is. He should write something up because I am thoroughly and totally confused. 10,000%. All right, we're gonna have to end it here, dude, and then we got to go do another thing, and then we'll be back on Thursday, and uh, I'm gonna look deeper into it, and then
Okay.
hopefully by Thursday we can share with everybody what we learned here. But if we do have to wait for the accept handler before we accept any connections, we'd have to do that on every iteration of this. Sort of can't just do it at the top of the go routine. You got to do it. Kind of got to do it everywhere. So I don't know. All right, let's end this, and maybe Jimmy will send us some information.
Okay. Sounds good.